Hey everybody, Dr. A here, and in this video we're going to be exploring another example of normal strain. So let's take a look at what we're given here. We're being told that two wires are connected at point A. Here's that point A. If a force F causes a horizontal displacement of 3 millimeters at point A, compute the normal strain developed in each wire. So let's take a look at the diagram. We have two wires, AB and AC, and each of these two wires is 200 millimeters long, and they're each at an angle of 35 degrees from a horizontal reference axis. And here's that kind of tensile force F that's going to cause that 3 millimeter horizontal displacement. Now, we don't know or really care about what the magnitude of F is. We just know that it's there and it's causing a 3 millimeter horizontal displacement at A. Okay? And so how do we calculate the normal strain in each wire? Well, under solution, the first thing I'm going to do is notice that this system is symmetrical. Okay? Now, whenever you have a symmetrical system like this, what you can do is analyze half of it. So we can either just analyze the top half, which is wire AB, or we can analyze the bottom half, which is wire AC, because what's happening in one of those two wires will be the same as the other one because of the symmetry, all right? So let's just look at wire AB. Let's look at the top half, all right? So I'm going to go ahead and sketch on here point B, all right? And I'm going to go ahead and draw my wire, okay? And here's point A, all right? And then we know that this thing is 200 millimeters long, and I'm going to go ahead and draw my angle here. This is 35 degrees, all right? Now, we were told that point A displaces 3 millimeters horizontally. So I'm going to draw another point over here, and I'm going to call it A prime. Now this distance, that distance is the 3 millimeters, okay? Now, what do we have here? Well, what we can build is a non-right triangle, okay? We can build a triangle that is not a right triangle, but it's a triangle that connects point B to A prime, okay? And so what we're going to do is I'm going to sketch another line here from B to A prime. Let me draw that a little bit better for us. Ooh, that got worse. Okay, so we have this straight line here, all right? And now what we have is this kind of elongated triangle here, okay? So the question becomes, how do we get the strain in that wire? And remember, whatever happens in AB is going to be the same as AC, so we only have to do this once, all right? So this length right here, I'm going to call this the length of A prime B, all right? Now, when we want strain, okay, the strain in AB is going to be equal to the length of A prime B minus the length of AB, all divided by that length of AB. Okay, now, do we know the length of AB? Absolutely. The length of AB is the 200 millimeters, okay? So what we really need is the length of A prime B. That's what we're getting right here, okay? So the question becomes, how do we do that? Well, we have this triangle here that's not a right triangle, and we might be stuck unless you remember what? Well, if you remember from trigonometry or even statics, we can use the law of cosines here to help us figure out LA prime B. Now, how do I know that? So if you remember your trig, whenever you have a triangle that's not a right triangle, and you want to relate its angles and sides together, there are two tools in our tool belt that we've learned. One is the law of cosines and the other is the law of sines, okay? And they work great whenever you don't have a right triangle that you need to analyze, okay? When you have a triangle that's something else besides a right triangle. So let's go ahead and see how we can apply the law of cosines here. So I'm going to look at this interior angle here. What is this interior angle in yellow? Well, that's going to be 180 degrees minus 35 degrees, which is 145 degrees. How do I know that? Well, this 35-degree angle and this yellow angle are supplementary angles, so they should add up to be 180. So that's how I know to do 180 minus 35, all right? Now, from here, you have that 145-degree angle. You have a side length of this triangle as 200 millimeters, and you have the other side length of this triangle as 3 millimeters, okay? So now what we're going to do is we're going to say LA prime B equals, and we're going to use that law of cosines, okay? And so what is that going to be? That's going to be the length of AB squared plus the length of A prime squared minus 2 times the length of AB times the length of A prime times the cosine of that interior angle. I'm just going to call it theta for now. Now, if you remember your law of cosines, that angle here that generically I'm calling theta, it's the angle that is the opposite of the length of A prime B, which is the length we're looking for, okay? And so I'm going to go ahead and populate these values. LA prime B equals the square root, make a long square root here, of 200 millimeters squared plus 3 millimeters squared minus 2 times 200 millimeters times 3 millimeters times the cosine of 145 degrees, okay? And so LA prime B, let's punch this through together. Be careful when you punch this in your calculator, okay? A lot of great room for error here. So 200 squared plus 3 squared minus 2 times 200 times 3 times cosine 145 degrees, and then we square root that whole thing, and we get 202.5 millimeters, okay? And we're almost done now, right? So now what we can do is we can substitute that LA prime B into our strain equation. And we're going to say epsilon AB is 202.5 millimeters minus 200 millimeters divided by 200 millimeters. And so finally, what do we get for epsilon AB? We get about 0.0123, okay? And that becomes our answer. Now, if the question asks for you to express this strain as a percentage, what do? You just take that value we just calculated and you multiply it by 100. And so as a percentage, you could express this as 1.23% normal strain, okay? And again, one more time, just to make sure we understand what we're looking at, this LA prime B comes from law of cosine. So if you're rusty on that, you need to look up some review information on law of cosines, all right? So that concludes this example. If you found this helpful, please hit like and subscribe and be on the lookout for content like this from other aspects of this playlist, or check out some of my other playlists, which has some other materials besides mechanics materials. Thanks for watching.